Hello everyone, in this video I'll be explaining about some more PDA examples. So first here we'll construct a PDF for a to the power n b to the power n language which is equal to a to the power n b to the power 2n such that n greater than equal to 0. So what's the meaning of this language? Whenever there is 1a, there has to be 2b's. Whenever there is 2a in the beginning, followed by that there has to be 4 b's. That's the meaning of this. That means number of b's are multiples of 2. Number of b's has to be multiples of 2. That's the expectation here. So let's understand the language. Language, when n is 0, it can contain epsilon. So when n is 1, that means a to the power becomes 1, b will become 2. When n is 2, b, so and so on. So this is how the language has to be. Then let us understand how to write the PDA. So now I'll start from the start state. Let me name this as start state. And since the language contains epsilon, so this start state need to be double circled. So this also should become an accepting state. Now what is my expectation in this language? So what is this says? Whenever there is 1a, you have to have 2 b's. Followed by that there has to be 2 b's. So you can observe here also for 1a there will be 2 b's. 1a there will be 2b. So that is why what I will do is, whenever I get 1a, I will push 2a's onto the stack. Okay. And then for 1b, I will pop 1a, and for other b, I will pop other a. Okay. So this is the adjustment I am going to make. So let us see this, as I have created a start state since the language contains epsilon. Now whenever I get 1a, I have to push 2a's onto the stack. Sorry, not here. I have to push 2a's onto the stack. So second field is about popping. Okay, next. Whenever I get b, I can't write here itself. That's why I should move to another state. So here whenever I get b, I will pop 1a from the stack. So more b, I have to pop 1a. So this represents if there are more b's, this will try to pop corresponding a's from the stack. Okay, this is about the PDA. Now let's see the computation on the input. So computation on the input goes like this. Now computation on the input for A, B, B is like this. I have to start from the start state. Take a input A, B, and comma epsilon. First character to be read is A. Okay. So first character to be read is A. So S on A input goes to where? It goes to S itself. So S on A goes to S, but it pushes 2 A's onto the stack. So onto the stack it pushes 2a. And then what are the after reading the first a, the remaining characters are A, B. Okay. Next I will have one more a. So for this also S on a goes to S itself. And this time what I will do, I will for 1a I will push 2 more a's, isn't it? So 2 more a's. So now what are the characters remaining after reading this? 3 b's will remain. Next what? Next S on B goes to F state. S on B goes to F state, and this time you will pop 1a. So you will process this and you pop 1a. So that's why 3 b's will remain and 1a will go. Next for one more B, F on B, F itself goes to F itself and it will pop 1A. So 2 B's will remain, 2 A's will remain. Then F on B again goes to F, 1B and 1A will remain. Next F on B goes to F, so F and input will be empty, stack content also will be empty. That's about the computation. And I have here even listed the 6 tuples of the PDA representations. So this is about the PDA on A to the power n, B to the power 2n. Now we'll see another example to construct a PDA, that is WCW reverse. WR in the sense reverse here. Okay. Now how to construct a PDA for this kind of a language. What do you mean by WCWR? W belongs to A comma B star. Suppose W is a string containing A and B. For example, W is containing A and B. What is W reverse? It has to be BA. And in between there will be C. So this string will contain at least the smallest string of the language would be C. And then it can be, suppose A is a W string, then W reverse will be A. So similarly, if it is B, C, B, if it is A, B, C, B, A, then you can see here if this is W, this has to be W reverse. So that's what the language. And now like FSM, since this is the C, we have to identify a C. That's why there has to be two states. S and F. And we have to make F as a accepting state. To accept C in FSM, we used to write the transition, write the FSM like this. There will be two states, one A and B, and this should be the accepting state. So similarly here you can see I have taken a start state and one more state. To accept C, this would be the transition. So next, first of all, let me tell you the idea behind this PDA. So whenever we get A, we need to push. That is, until you get C, leaving C, whatever A, that is the string you are getting. Okay, before you encounter C, whatever string you are getting, that you are supposed to push it onto the stack. Okay, first A, then B, you go on pushing. Once you get C, just read the character. Don't do anything. Just read the character and move to the next state. Okay, but whenever you get B again, this B, what you have to do is you have to pop this from the stack. Whenever you get this, you have to pop this A from the stack. Okay, that is what you have to do in case of the PDA conversion. So that's why I start from here S and I will just read C. As I said, I will not do anything for C. I'll just read that C character because it is the only character I get and I don't want to do anything on that. Okay. So next is regarding whenever before C, if you get A or B, that has to be in the start state itself. In that case, what you are going to, whenever you get A, you just push it onto the stack. Whenever you get B, you just push it onto the stack, and this middle field should be empty because that represents a popping character. Okay, as soon as you get C, you move to the next state, and that will be the final state. And what you do at this state, in this state, whenever you get B, you pop B, and remember here push field is empty. Whenever you get A, whenever you read A character, you pop which character? A itself. So that is what shown in the WCWR. For this, you can write the 6 tuples like earlier. I have shown already in the previous example. You can see that and write the 6 tuples. Now we'll see the computation on input. input ABC, ABC, BA, ABC, BA. So we have to start from the start state. As usual, we have to start from the start state, and then the characters, the strings, string is ABC, BA, and the push, that is stack field is empty. Stack field is empty. This is the input string. Okay. Now, when you apply the transition on A character, S on A goes to where? Itself. So you can see here S on A, when you read this character, you go to S itself, but you S on A, you just push that character onto the stack. So that's why A is here. Okay, that character you're supposed to push it onto the stack. Next, what is remaining here after reading A? B, C, B, A. S on B, S on B, S on B goes to S. Next character when you read, it goes to S. So, and push which character? B character on the stack. So that's why B is on the top. So latest pushed element will be on the top. That's why BA will come. So next, when I read C, whatever S on C, it goes to F state. You can see here, I've gone to S state. But don't do with this C character anything. You don't push it onto the stack or pop it from the stack. You just read that. That's sufficient. So that's why the input character will remain only BA. Okay. Next, when I get B, F on B now. Now next character to be read is B. F on B, pop B. F on B, pop B from the stack. So you have to pop this from the stack. So input character is also over. Then what is remaining in the input? A and A. Now when you read A, now this character to be read. When you read A, pop A. So this also gone, this also gone. Finally what is remaining? F comma epsilon comma epsilon. So in this state you can check whether it is F is an accepting state. Yes. Whether the stack input character is field is empty. Yes. Whether the stack field is empty. Yes. So that means this particular string is ABCDA is accepted. Now we'll construct a PDF for PAL event. PAL event, the constraint goes like this, that is W reverse such that W belongs to A comma B star. Okay, suppose W is a string containing A, then W reverse will be A. So total length of the string would be even. So that is what PAL event. So some examples are like this: epsilon, A, B, B. All these are the examples. So how to identify or how to construct a PDA for this? How to identify this kind of a strings through PDA? So that's why let me start from the start state. Start state. Okay. So I will take a start state. And here you can I am not going to make start state as final state, though it contains epsilon. Instead of that, what I will do is I will create one more what to call I will go to the final state without consuming the input like this. When you don't read any input character without consuming anything, you just shift to a next state. This is what I am going to do. The requirement of this particular thing I will explain later. First let me explain how exactly we are going to do. So whenever you get if in your string, if there is AA, then there has to be equal AE. Okay. So what I will do, whenever I get A in the beginning, I will push it onto the stack. When similarly, if I get B, something like this, 2 B's and 2 B's, this is obviously WR. So whenever I get B, I will push it onto the stack. Okay, and I will just move to the next state, and here what I will do, after reading 2 characters I can go like this. Then whenever I get A, I will pop A. Whenever I get B, I will pop B. This is what the PDA will be. So I have written the tuples also for the PDA. Next I will show one more PDA for W belongs to A comma B star such that number of A in a string is equal to number of B in a string. So number of A's and number of need to be equal. So this is the example, and here epsilon is there. I have made start state as epsilon, and in the start state, because equal number of A's and B's, it can be anyhow. It can be A, B or B, or there is no fixed order for A, B, A and B. Okay, that is why I will finish in the start state itself. So whenever I get A, what I will do, I will push A. So suppose if there is a string like this, what is that? A, B, A, B. There are equal number of A's and B's. Okay. So there is no particular order for A and B. That's why I can finish this everything in the start state. Whenever I get A, I will push it onto the stack. Whenever I get B, I will push it onto the stack. When I get A, I will pop what? 1B from the stack. And when I get B, I will pop A from the stack. This is how I am going to do. Okay. So when I get A, I have to pop 1B. Okay. So for example, if it is A, B, B, what I will do? Whenever I get A, I will push it. One more A, I will push it. For B, what I will do? For B, I will pop A. For B, I will pop A. And next B, I will pop one more A. Okay. This is how the number of A's of string equal to number of B's in the string goes. So these are the some cases for PDA.